about finding volume by the washer method again. So direction-wise, let's take a look at a couple last special cases over a horizontal axis. So we're going to just go ahead and put our boundaries up again. We're going to use y equals the square root of x. We're going to use y equals 0, and we're also going to use x equals 9. And we want to revolve about the line y equals 4. Now, what's different between this one and one from a previous video is I've bumped up the axis of revolution to 4 instead of 3. So let's draw the picture and see what it is that we are looking at specifically. So y equals the square root of x, y equals 0, x equals 9. This is the region that I want to rotate. But what's interesting about this is if I put 9 in here to the function, I'm at 3. So this is y value 3. Well, I want to spin this around the line y equals 4. So it doesn't matter if the line is y equals 3 or y equals 4, I still do the same thing. So at the end of the last video, I shared this little fact with you, that this region right here, it has a height or a radius, because again, we're rotating. It doesn't matter what the axis is when we're rotating. When we're rotating things, this axis is always going to be a height of the square root of x. Now, this axis that goes all the way through, okay, because we're up here rotating around 4, that has a length of 4. And so what we have left over is we have this piece that we, in theory, want to get rid of. Well, how long is that? Well, that region right there would be 4 minus the square root of x. So we can put that kind of into that context then. So how does our formula change? Well, it doesn't change a lot. I'm going to need pi. I'm going to integrate from 0 to 9. And the first thing I need is I need this big rectangle that I'm going to rotate. Well, that rectangle is going to move back and forth between 0 and 9. And it's going to rotate. So that's going to be 4 squared. Now, I need to take away this piece. This piece right in here. All of that's going to go. So, what do we know about that? Well, that piece right there is 4 minus the square root of x right there, isn't it? So, that's what I'm going to take away. I'm going to square all that with respect to x. So 4 represents the original. 4 minus the square root of x represents what I want to get rid of. And that'll leave me with this right here. So I'm taking this big rectangle minus this right here. That's going to leave me with the region I want to rotate and have left when I do. So last but not least, when we rotate this way, in the previous concept, we worked with area between curves. So how does that work out in this context? So let's do this. We're going to find volume this time, but we're going to use f of x equals x and g of x equals the square root of 4x. And we want to take the region that's bounded by those right there, and we want to revolve about the x-axis. Okay, so first of all, we need to get a picture of this. So f of x equals x. That is a linear function. That's something like so. G of x equals the square root of 4x. Well, what that's going to do is if I put 0 in here, I'm going to be down here at 0. And if I put 1 in, I'm going to be up here at 2. So I'm actually going to be above here. And so what I have to think about is boundaries. So let's set x is equal to the square root of 4x. Let's set those equal to each other. Now solving that, square both sides first. You cannot divide by x. So we've got to move that 4x over. Thus, we are allowed to factor. And therefore, we get our boundaries at 0 and 4. So we are out here at 4 as well. And so this is our region right here. And we want to take that and rotate it this way. Okay, so it's like a little moon shape that's going to rotate. So it has a massive cone that's being taken out of this shape. Almost like a clamshell, almost, it kind of looks like. All right. So what do we need? Well, the first thing we need is, this is washer method again, because we've got this massive gap here. And this part's going to have to go away. So what I really need is, I need to figure out the volume of this piece and take away the volume of the triangle basically inside. Now, you could go ahead and just find the volume of that triangle and put it as a number, but always write things as integrals, folks. All right, so first thing, pi, integrating from 0 to 4. How tall is this? Well, this whole thing has a height or a radius of the square root of 4x all squared. But I've got to get rid of this piece. And how tall is it? Well, it has a radius, that's always x. So we square it with respect to x, and we are done. And that is how you work with a horizontal axis. Everything is in terms of x. It doesn't matter if it's the x-axis, y equals 3, y equals 4. It doesn't matter if you're using 2 curves. Heck, you could even do 3, I suppose, if you wanted to as well, but we won't. So that's the washer method over a horizontal axis. Still have to cover the vertical axis ones. That's all in terms of y, and that's coming up.